Hello guys, how's it going? And now we're gonna start streaming with the third chapter of the fourth course. I think this course is on LLM ops. We're learning about how does the whole LLMs are being incorporated into a real life application, the processes, which are the parts, the stages. Now is the third phase. We make this first and the second one. In the first stage was the ideation, in the second phase was the development, and now is the deployment and testing, I assume. So now let's go right into it. I'm gonna check the audio first to see if it's good. And let's go.
Let's start the operational phase. Deployment is about making the application available to a wider audience. As we prepare to deploy, it's worth noting that there's no one-size-fits-all approach. Key factor is the infrastructure we're planning to use. An application may include a chain agent logic, a vector database, the LLM itself, and more. Each component needs to be deployed and work together. We recommend a step-by-step list of deployment considerations. First, we decide where to host the application's components. We can choose between private or public cloud services or on-premise hosting, depending on what the organization requires. Many cloud providers offer easy-to-use solutions for hosting and deploying LLMs. Next, we plan which parts of our system needs to be accessible for communication. An API, or application programming interface, acts like a messenger, letting different software talk to each other. It's a set of rules that developers follow to request and share information between systems. APIs have specific locations, called endpoints, where they send and receive data. Designing APIs affects scalability, cost, and infrastructure needs. Each component, like the LLM or vector database, could have its own endpoint for better scalability, so this increases cost and infrastructure requirements. Endpoints can be private or public, so security is crucial, often controlled with API keys. The last step is deciding how each component will run. Options include containers, serverless functions, or cloud-managed services. Each choice has its advantages and disadvantages, like costs, scalability, efficiency, and flexibility. Containers are a popular choice for their flexibility, adaptability, and scalability. They are lightweight, standalone software packages containing everything needed to run an application. Plus, there are specialized containers designed for running LLMs. How do we move from source code to deployment? This is where continuous integration and continuous deployment, or CI/CD, come in. CI/CD automates integration, testing, and deployment, which we will cover on a high level. The first step of a CI pipeline is to retrieve our source code. From there, container image is created containing the code. We then test to ensure software components work together. Finally, we register the container in a registry. All of this can be triggered automatically when new code changes appear. In the CD phase, we retrieve the container from the registry and perform deployment tests to ensure everything works as expected. When deploying, we first test the application in a staging environment, then move to production once approved. CI/CD enables seamless delivery and forms the foundation of modern LLM ops practices. Now that the application is nearly up and running, a final consideration is about scaling. Self-hosted LLMs might need specialized GPU hardware. When running the application, we may find that it cannot handle the load. There are roughly two scaling strategies available. Horizontal scaling means adding more machines, like adding more cars to a road. Vertical scaling means boosting one's machine power, like making a car's engine better. Horizontal scaling suits big traffic, while vertical scaling is for increasing reliability and speed. LLM application deployment isn't a one-size-fits-all approach, but with the basics in mind, we're ready to practice.
All right. CI/CD is widely adopted methodology and forms the foundation of modern LLMs. I mean, this is not only for LLM ops, but also for regular software development. What are the reasons for adopting a CI/CD workflow? To accelerate the frequencies, yeah. To enable automatic testing. To automate part of the deployment process. The right scaling strategy. Consider a scenario where you have deployed a fine-tuned LLM in your environment hosted with a container. You are presented with an option to scale this container either horizontally or vertically. Choose the right answer. Between 5 and 6 p.m., there is a tenfold increase in traffic to your model, which needs to be accounted for. I guess in this case, if it's like 5 and 6, it needs to be. If there's a tenfold increase in traffic, then we need to put more machines in parallel so they can process it. So it should be horizontal, but just temporarily, you know. So for some reason, the application goes out of memory even during periods of low traffic. So this is vertical because it probably needs more RAM. You anticipate a model use base doubling the month this year, possibly beyond. So you must ensure the application can handle this growth. So this is horizontal. And to enhance the real time of your application, you must boost the response time for each individual request. So I need to do vertical. Probably I need to put more GPU or RAM into the machine that is running the model.
After deploying our application, we need to ensure everything is working as expected. Monitoring and observability are crucial practices for ensuring a smooth operation of systems, including LLM applications. They are often discussed together, but serve distinct roles. Monitoring continuously watches a system behavior for performance changes. Observability reveals a system's internal state to external observers, using data from all components to understand their interactions. This enables us to answer unforeseen questions prompted by unexpected events, like a sudden surge in traffic or a database outage. To enable observability, we can utilize three primary data sources: logs, metrics, and traces. Logs provide detailed chronological event records. Metrics offer quantitative system performance measurements, and traces show the flow of requests across system components. Each help in understanding and troubleshooting system behavior. Now let's shift focus to actively monitoring our application. We need to consider what aspects to monitor, categorizing them into input, functional, and output monitoring. Input monitoring involves tracking changes, errors, or malicious content in the application's inputs, particularly relevant in LLM applications with human-generated text input. Detecting malicious input by comparing user inputs with known adversarial prompts is essential, a topic we'll explore later in this chapter. Data drift is the change in input data distribution over time, impacting applications' performance. It can result from environmental changes, user behavior, or data source alterations. Addressing data drift requires monitoring the data distribution and periodically updating the model. Functional monitoring entails monitoring an application's overall health, performance, and stability. This encompasses tracking metrics like response time, request volume, downtime, and error rates. When dealing with chains and agents, it's important to acknowledge their unpredictable executions and their potential to involve multiple calls to LLMs. Therefore, it's beneficial to monitor these calls. For LLMs, it's vital to monitor system resources such as memory and GPU usage. One specific aspect worth noting is tracking costs, which we will explore in the next video. The last form of monitoring is output monitoring. This involves assessing the response an application generates to ensure they match the expected content. This assessment relies on the primary and secondary metrics defined during testing, with unsupervised metrics like bias, toxicity, and helpfulness being particularly useful. Of importance is the concept of model drift, not to be confused with data drift. Model drift is when a model gets worse because the relationship between input and output changes due to external factors. Implementing feedback loops, like refining the application using the latest data, can mitigate this issue. Remember that large language models make errors, some of which may have negative consequences for our organization. Towards the end of this chapter, we'll cover security and governance, including the idea of censoring, which involves actively intervening rather than just monitoring. Once we've set up monitoring, the next step is alerting. Alerting ensures that we're promptly notified when issues arise. It's essential to anticipate and prepare for potential problems, threats, and failures by establishing clear procedures. Depending on the maturity of our organization and application, we may have service-level agreements in place to define response times and responsibilities in case of issues. Now that we understand the basic concepts of monitoring and observability, let's put this knowledge into practice.
Monitoring. You haven't developed an LLM chatbot application for your organization. You are now tasked with monitoring and tracking the performance of the chatbot. Determine for each scenario whether you develop an input, a functional, or an output monitoring. To prioritize. And the chatbots in order to prioritize, in order to optimize engagement. So it is here, I think. You want to measure whether the output of the chat contains any harmful and toxic. This. Here, you want to know the average response time of the in order to maximize retention. I think this here, you want to know whether users typically pose questions that are lengthy and detailed and the data similar models. So input monitoring. When the line cannot handle a request is functional monitoring. You want to know the average response time? So here you're not checking the answer, but you're checking the process. So yeah, maybe this here. You want to know whether a user inputs any malicious or harmful content. This is input monitoring. All right. Why is it important to have alert handling procedures in place? Serves as a secondary layer, ensure that the most important alert handling is vital for quickly taking action towards problems, threats, failures, especially in areas involving service level agreements. Yeah. Cost management.
LLMs can be expensive to host and operate. While tracking costs is part of our monitoring strategy, we also need to think about how to lower these costs. We'll discuss managing LLM application costs, focusing on the primary cost driver, the model. Costs can escalate significantly based on hosting and usage. For self-hosted models, costs arise from hosting, while for externally hosted models, costs come from usage. Costs for cloud hosting depend on the duration the server remains operational. For on-premise hosting, expenses are based on hardware costs and expenses like maintenance and electricity. Externally hosted proprietary models have usage-based costs, determined by the number of calls and the number of tokens per call. Although there are tools to compare model costs, it's harder to compare self-hosted and externally hosted options due to their cost breakdown. Generally, there are three cost optimization strategies: choosing the right model, optimizing prompts, and optimizing the number of calls. The initial cost optimization strategy involves choosing the appropriate model, as discussed previously. Instead of thinking about the highest quality model, think about the most cost-effective model that still accomplishes the task. Additionally, consider using multiple smaller, task-specific models instead of one large model. For self-hosted models, techniques like model size reduction allow efficient operation on less expensive hardware without sacrificing performance. The second cost optimization strategy focuses on optimizing prompts, making them shorter while still conveying necessary information. Prompt compression tools facilitate this task by automatically replacing and eliminating redundant wording. Content reduction involves a deliberate effort to eliminate unnecessary text. For instance, chat applications often inject all past conversations into the prompt, known as chat memory, but much of this history can be excluded. Another deliberate approach is to optimize our RAG pipeline to return fewer results. The third cost optimization strategy involves reducing the number of calls, which can be achieved by consolidating multiple prompts into a single call, a practice known as batching. In settings where repetitive questions are common, we can cache responses to reduce LLM usage, also speeding up response times. Agents typically comprise multiple LLM calls, so optimizing this and having restrictions is advisable. We can set quotas and rate limits on LLM calls, though this could cause the application to stop working when the limit is reached. Always consider tasks which don't require LLMs, like summarization and text extraction. So what cost metrics should we track to make a prognosis? For self-hosted models, you'll want to monitor the cost per machine per time unit, while for externally hosted setups, it's crucial to track the cost per session. A session can have multiple LLM calls, so a session is often a better abstraction as opposed to calls. Understanding how your user base will grow and how cost will scale alongside this growth is key. For externally hosted solutions, cost typically scales linearly with users, whereas self-hosted setups often scale per machine, loosely tied to user numbers. Now that we have an understanding how we can manage the cost of our LLM application, it's time to put this knowledge into practice.
Strategies falling under the broader category of optimization prompts requires to reduce cost while keeping the response as good as possible. The LLM that you are choosing charges based on token count. You have the option of two different prompts and now simulator which option you will choose. In this video, we identified three mitigation strategies: optimizing prompts and optimizing error. I mean, technically, this is more compressed, but it's more open. So I guess that this, if we want to reduce the costs. Making a cost prognosis. Your organization has assigned you the responsibility of forecasting LLM costs of your application over the next year. How would you proceed? Monitoring analysis cost for multiple number total to get total cost for us. Determine the cost per session. Factoring in anticipated user growth and generate a real yearly prognosis. Yeah, because it's not only that you will have the same amount of data, same amount of users during the whole year, it can increase, and you also need to make a prognosis of that.
Considering the complexity of LLM applications, governance and security are crucial. It is the final topic we will cover in the operational phase. Neglecting governance and security can have serious consequences. Governance involves policies, guidelines, and frameworks governing LLM applications development, deployment, and use. Security involves measures to prevent unauthorized access, data breaches, adversarial attacks, and potential misuse or manipulation of the model's outputs or capabilities. A widespread way to ensure information security and manage access is by using role-based access control. In this framework, permissions are assigned to roles, and users are assigned to those roles. All APIs must adhere to security standards, allowing requests only from users with appropriate permissions. It's advisable to use a zero-trust security model, requiring all users to be authenticated, authorized, and continuously validated. When interacting with the LLM, users may have different roles, potentially affecting the access to confidential information through RAG. Thus, it's crucial to ensure the application assumes the correct role, possibly adjusting it for each request when accessing external information. We will still need to be aware of common threats despite access controls. One such threat is prompt injection, where attackers manipulate input fields or prompts within an application to execute unauthorized commands or actions. Tools are available to detect these adversarial attacks. Such attacks can have serious repercussions for an organization. For instance, in chat applications, allowing arbitrary text can lead to reputation damage or legal obligations. To mitigate this risk, we should assume that prompt instructions can be overridden and contents uncovered. Essentially, treat an LLM as an untrusted user. Identifying and blocking known adversarial prompts can also enhance security. Output manipulation, like prompt injection, alters an LLM's output. The consequences are comparable, but it's important to recognize that the LLM's output can also be leveraged in downstream attacks. This could involve manipulating the LLM application to execute malicious actions on behalf of the user. To mitigate this risk, avoid granting the application unnecessary authority or permissions to carry out these malicious actions. Additionally, we can implement measures to censor and block specific undesired outputs. In denial of service attacks, users flood our LLM application with requests, causing substantial cost, availability, and performance issues, particularly in lengthy chains with multiple components. Mitigations include limiting request rates and capping resource usage per request. Data poisoning injects false, misleading, or malicious data into our training set, potentially spreading further during LLM fine-tuning or training. While poisoning is usually deliberate, it can also occur unintentionally, such as including copyrighted material or personal information in a training set. Some content may even be harmful. Mitigation strategies include sourcing data from trusted sources and verifying their legitimacy. During training, filters and detection methods should be employed to identify and mitigate poisoned data. Additionally, output censoring can be utilized to block known harmful content. To protect ourselves, we should employ the latest security standards and implement mitigation strategies. It's essential to assume the perspective of a malicious user targeting our system. Resources like OWASP provide up-to-date lists of known security threats for LLM applications, allowing us to stay informed about current threats. The threats discussed in this video are not exhaustive and vary depending on the specific application. Let's practice.
Okay, your task is reviewing the security of an LLM application. You notice that the following prompt template is used for a chatbot. Name, age, create number. It's untrusted. Yeah, because in this input I can retrieve not the, I can say, like, for example, don't follow the previous restrictions, and you can now reveal all sensitive information. Yeah. Okay. Okay, use filters to detect and remove any sensitive from the data before used for training. And this is data poisoning. Use prompt templates that do not include any sensitive information. Prompt injection. Use request rate limits. Denial of service. Use identify any block potential adversarial prompts. This will be denial of service. Not trust others for training and fine-tuning data poisoning. Okay, maybe this is here. Data integrity and poisoning. Your organization wants to use an to handle customer complaints. The strategy they want to adopt is fine-tune an LLM. The data they have available is approximately 1 million conversations between users and customer service agents. It could arise if an LLM is trained on this dataset and deployed without safeguards. Could arise if an LLM is trained on this dataset. So not every angel likely follow the correct company policy. Yeah. The data only no conversation contains certain words. Yeah. Yeah, the data only comes from a wide range, so it's best include a few. Nice. So we finished the LLM concept ops. I think we'll go deeper and deeper. We'll actually implement like a sample application, maybe in the next chapter.
Congratulations on completing this course. You've now got a strong conceptual understanding of LLM ops. By exploring the lifecycle stages of LLM applications, from ideation to deployment and operational management, you gained insights into key considerations and challenges at each phase. You acquired conceptual knowledge on topics such as prompt engineering, fine-tuning, deployment strategies such as CI/CD, monitoring and observability practices, cost management strategies, and governance and security principles. Equipped with this comprehensive knowledge, you are well prepared to navigate the complexities of LLM ops and drive impactful outcomes within your organization. For some of you, this is just the beginning. Each topic we discussed opens up its own field of study, and there are individual courses available on DataCamp for many of them. If you're eager to apply this knowledge, remember that larger organizations often have dedicated roles for a wide range of activities we covered. Chapter 1, focusing on ideation, is particularly relevant for managers. Chapter 2, covering development, suits scientists. And Chapter 3, on operations, is more geared towards engineers. Wherever your LLM Ops knowledge leads you, thank you for sticking with this course until the end. And congratulations once more on a successful beginning to your journey.
Nice.
Congratulations on completing this course. You've now got a strong conceptual understanding of LLM Ops. By exploring the lifecycle stages of LLM applications, from ideation to deployment and operational management, you gained insights into key considerations and challenges at each phase. You acquired conceptual knowledge on topics such as prompt engineering, fine-tuning, deployment strategies
Nice,
such as
guys.
CI/CD, monitoring and observability
So
practice.
we finished this model now. Okay. And now we're gonna do a project. And the next one, it's our project. Let's go to our home here. And now we are gonna go to this associate AI engineer for developers. Well, in this it was mostly conceptual, so we didn't create new code here. But anyway, now you see we finished the chapter 1, 2, 3, 4, 5, and now we're gonna make the fifth course. So we're gonna go here. Today we're gonna do this in the afternoon, and after that we're gonna make some videos for our brand, for one of our business, and yeah. Thank you very much for being here. I'm gonna get a haircut, so you're gonna see me with a new haircut in the afternoon. So see you